thanks everybody for joining. And I put the link to the working doc and then just add in any agenda items you want to. Otherwise, we'll take it over to Lynn.
Okay, great. Hi, everybody. Let me send out this link. I guess I can share my screen, might be easier. Let me figure out how to do that.
I can post the link in the chat if you want to share your screen.
Yes, so I think I got my screen shared. Can you guys see the Istio community roles page?
Yep.
Okay, awesome. So the technical steering, I should say technical oversight committee has recently met to discuss what becomes a member, what makes it a user become a member of the Istio repository. And the reason we did it is because we've got a lot of random requests among our contributors. People wants to become a member. They were not sure what's the process. So we feel like it's a really good time for us to huddle together. So this is the new process I want to talk to everybody through. So within this roles page, you can see to request to be a member of the Istio organization, you can open an issue, which we'll get there next, and then fill out the required template within the issue. So if you happen to click on the link to open the issue, you'll see it's basically a GitHub issue in the Istio community repo with the title pre-fill for you. And it also has a pre-fill template. Within that template, we basically ask you, what's your GitHub ID, which company are you with, or if you are individual contributor, that's welcoming too. And a bunch of requirements to become a member. So we require you to, such as, read our documentation on membership guideline, a contributor guideline, make sure your GitHub ID is secure, make sure you subscribe to the Istio Dev mailing list. And also importantly, to document your contribution to the project. So we view contributions such as authoring or review PRs on the GitHub, be able to commenting and providing information on the issue, be able to contributing to work group, and also the community discussion like this. And then the other requirements also have people to sponsor for you to be able to willing to sponsor your membership. And then we also have a little bit of sponsor requirements that the sponsor can't just be randomly anybody who is an existing member. We would like it to be who has close interaction with the member, the to-be member, the user who's proposing himself to be a member, and be able to interact with that user either through PR, either review that person's PR or approve that person's PR or interact on the design doc. And then the sponsor has to be at least in one of the owner's file in any of the Istio repository. In fact, we just had a discussion yesterday. I think we may tie that a little bit up, not only to be any of the Istio repository, but not counting the repository of our documentation repository, because our criteria for becoming owner for that repository is slightly different than any of the other repository. And then also be able to demonstrate sponsors are actually from at least different companies, so that this is demonstrate this is a community interest to have you as a member. And then you basically list your sponsors and indicate whether you have spoken to your sponsor, and also document your contributions in detail. And also, if you, as part of the privilege for being a member, you also get to join the developer Slack. So you are welcome to providing your email address so that we can invite you to join our developer-only Slack. So that's essentially the process. I don't know if I missed anything, April.
No, I think that covers it all. Does anybody have any questions or feedback on this? It should be, I believe it's based on what Kubernetes uses, so it should be pretty familiar to most. You may have already gone through this with Kubernetes.
Yeah, and it's a new thing we are rolling out, so we certainly welcome you guys' feedback on this too.
All right.
Okay.
Sounds like there's no questions. Thank you so much, Lynn, for covering that. And yeah, by all means, do check that out. If you see something that you think should be clarified or you want to get a little more understanding of, do create an issue in the repo. Let us know how we can make that clearer for you. But this should help streamline things and make sure that those of you who are needing to be active in the org get set up to do so. All right, so we've been having a lot of questions about Mixer on a lot of the recent calls. So I asked Mandar if he could join and kind of walk folks through some of the basics and stuff around Mixer. So Mandar.
All right, thanks, April. I will share my screen. Okay. Do you guys see it?
Yep.
And okay, so one of the things with the deep dive is that it's always unclear how deep, right? So I have calibrated this to a certain depth. However, if during the call, people on the call think that it's either too shallow or too deep, I can always adjust it. So
Mandar, kudos for using the nautical-based puns already. I like it. I like it a lot.
Okay. Why the hell does it not start? Okay, I can't see. Ah, there you go. Okay, now I don't know if Zoom is correctly doing this, but I see my presentation on my screen, so I guess works for me. Okay, so we first I'll just go briefly through kind of why, what, and how. Actually, what and how is the meat of this talk, but why is like why we need such a thing, right? And before that, just let's go over the basic Istio architecture, right? So there is there is Envoy, which is going to intercept all the requests and make two calls to Mixer, one on the check path, which is one before the request is sent to its final destination, and one after the request is sent back to the requesting source. So the first one is check, the second one is report, and this is just to show where in the architecture Mixer fits, right? This is a bit backwards, but I think it's useful to put it here. So why do we need such a thing, right? Now, from a very high level perspective, a service mesh needs some precondition checks. We need to decide if a request should proceed or not. We also need rate limits and quota kind of checks. So to decide if a request is otherwise fine, but there are too many of these, so something should be rate limited. And then we need observability. We need to collect telemetry. Now with all this, another thing that's important for a service mesh is that it be extensible and easily extensible. So we have to have the ability to add these above functions easily. And then it's also an integration point. So there are many existing systems which either perform these three functions or so for example, for metrics, there are metrics collection backends, right? So we want to be able to have a system that integrates easily with these existing systems. So that's kind of the purpose of why we do this. So what is the Mixer abstraction, right? Now we are not yet getting into the implementation, but what is this abstraction? What are we presenting to the user. So we're defining a uniform configuration surface. And I'm using metrics as an example here, but in the previous slide, I showed that it's checks, metrics, and quota. So all these apply. So all the further discussion applies to checks as well, but metrics is just easier to talk through. So the uniform configuration surface talks about when should you collect a particular metric. It also talks about how you should collect that metric and where to send the metric to, right? So this is the uniform configuration surface, which is quite agnostic to specific implementations. And I'm stressing this point because some of it is going to be important later. And then one level deeper, Mixer also defines a couple of APIs, right? So the first one is the Mixer API itself, which is a gRPC-based API. And in some ways, it's actually an internal detail between the proxy and Mixer. You can go read about details of that API, or if someone wants to know now, I can talk a little bit more about it. But at this stage, it's a front-end API, and it's between the proxy and Mixer. Mixer also defines a bunch of meta APIs, which are defined by the templates. And at this stage, since I have not gone through template details, let's just leave it at that. But it is a meta API, and every template essentially defines its own APIs. And crucially, that API is between Mixer and the adapters. So in terms of the configuration surface, again, when to collect is the rule. How to collect is the instance. So you define the mappings there. And handler is where this collected instance is sent to. So here is an example. I'm starting from an example, and I've elided the Prometheus handler here because well, first of all, it will come later, and it's not that detailed anyway. So in this case, what we want to achieve is that if you have a certain request header, right? I'm just making some header up called x-collect equals to true. If that header is present on the request, then you want to collect a metric, which is request count by service, and that is defined on the right-hand side, which says the two dimensions are source and target service, and source is source workload, and target is target service. So when you push this configuration into the system, what we expect is if you go to Prometheus, these metrics should show up there, right? That there is a little bit. So again, disregarding any implementation, what we expect from this configuration is that if this header is present, we expect these metrics to show up in Prometheus. So now we're going to go through the Mixer stack to find out how this actually comes into being, right? How these things are materialized. So first, let's just set up like a simple life of request, right? Because the request starts from some client. It's trying to go to a service intercepted by Envoy. Now, this is where the Mixer API comes in, right? This is the first step. So Envoy is going to translate or package up all the information that is available to it in this attribute-based Mixer API. And then Envoy calls check, and then it calls report. And now we're talking about report, right? So again, now we're at the top of the stack. Mixer API is internal between proxy and Mixer. It uses some compression techniques to reduce the amount of data that's transferred back and forth. There is also batching, which means fewer number of calls are made. And for check specifically, there is also a very efficient cache implementation, which makes sure that calls are not made on every request. There is a very good cache hit rate. So the next step, once the request is received by Mixer, it receives all these attributes. Now, some of these attributes have to be augmented. One example, and this is kind of mainstream, it's always used, is the Kubernetes env adapter. So Envoy sends source UID, right, or destination UID to Mixer, which is the pod identifier of the pod that's talking to Mixer. At that point, Mixer is able to ask the Kubernetes environment adapter to resolve the pod and get all the labels, so they get all the metadata associated with it, which is labels and annotations. Similarly, you can have derived authenticated principles. And these kinds of adapters, you can imagine there could be many more, right? There could be Kubernetes, console, any other service registry, right? That ID is known to the service registry, and the idea here is that you can go back to the service registry and ask for more information. Again, this is all cached. Once that step is done,
can we ask a question on the previous
Sure.
step? So this is one thing that been puzzled with me. So I remember, so we recently added support for running minimum Istio, where you run Istio without Mixer.
Mm-hmm.
So you can still do basic networking traffic management function without Mixer. You basically just run Pilot, right?
Correct.
So one thing I did find out the other day is once I add Mixer in, even before I had any Mixer policy or authentication policy,
Mm-hmm.
the traffic from distributed tracing, that goes to Mixer. So I think this is a Kubernetes adapter you were talking about. So how is this adapter being used even without user using any Mixer policy? Is that true as long as Mixer is in the picture? Because if Mixer is not in the picture, obviously in the distributed tracing, my call is not going through Mixer.
Yeah, so yes, I can answer that. So the way when you put Mixer in the mix, so to speak, we generate, like Pilot generates configuration that will ask Envoy, right, that will insert the Mixer filter into the filter chain at Envoy. Now, we don't have the optimization yet anyway, right? And this is definitely on the roadmap. We don't have the optimization yet that says that if there are no policies applicable for a particular service or no policies at all, then just elide the call. So I think that's what you're referring to. So we don't have that yet. However, so what ends up happening isn't actually that bad. So what ends up happening is Envoy still calls Mixer. Mixer says that, well, the call is allowed to go through because there are no policies that are going to affect you. And that information is cached in Envoy.
Okay, so it's a one-time call to Mixer.
So one-time call to Mixer, I mean, the cache has a TTL. So once the TTL expires, it's going to go back. And that is the reason why you see that call going to Mixer, even though you don't have any policies. But that's a good point. It is definitely on our roadmap, has been on our roadmap to say if you can just elide it completely if you don't have any applicable policies.
Okay, that makes sense. And a side question where you were just talking, you mentioned about when Mixer is in the picture, you would have this Envoy filter injected in this Envoy sidecar. So does that mean if I'm a user, I move from network-only profile to a profile that including Mixer, I would need to redeploy my control plane to pick up the new Envoy with the filter?
You don't have to redeploy your control plane, right? So
the data plane.
No, you don't even have to redeploy your data plane. So as long as you're using Istio proxy, right? As long as you're using that binary does have Mixer client compiled into it. In a
Okay.
no mixer configuration, simply the configuration does not ask Envoy to load the mixer filter. And when you change the configuration and Pilot starts generating mixer filter configuration, Envoy will load it. You don't need to redeploy.
Okay, so it's a dynamic push that I don't need to even restart the proxy.
No, you don't have to restart the proxy.
Okay, that's good to know. Thanks.
Yeah. So getting back to our flow. So after the first step of knowing extra information about the request, right? Metadata about where it came from and where it's going, we move on to this adapter resolution phase. So adapter resolution decides which of the adapters are going to be invoked for this particular request and which of the adapters apply. So in the rule, right? Okay, so here is the rule, right? Now, match condition here is true, which is like always true. In the previous example, I actually had a real match condition. Whichever way, the first part of resolution is to decide if a particular condition matches. In this case, it will match. And then we collect all the actions that are associated with that rule. In this case, the action is send request count by service instance to the Prometheus handler. Now, you can imagine that there can be many kinds of rules, right? So in our original example, we conditionally dispatched this instance to a handler. In this example, it's doing so unconditionally, just saying, always collect this metric regardless of what the request says. So adapter resolution now, at the end of this phase, we know that for this particular request, we need to produce certain instances and send them to certain handlers, right? So that's the end of adapter resolution phase. Now, the next phase is attributes to instance mapping phase. So that is when we actually produce the instances to send to the adapter. Now, this is the instance configuration. It is based on the template proto, which defines how a metric template looks like. And metric template is fairly simple. There is a value, which is a scalar, and there are dimensions. Dimensions are normally just string to string, but they can be a little bit more. But string to string is the simplest to think about. So in this case, we wanted dimension on source workload and target service, right? Now, source workload and target service both are attributes that were either sent directly by Envoy or that were derived by the Kubernetes env adapter on the way to coming here. So there is so during this mapping phase, it takes as input the attribute bag, which is the attributes that have come from Envoy, and it takes this template proto. And what it then produces is, and this is kind of going into some of the Go code, but what it essentially has to produce is it has to produce a struct of this type, right? So the value is int64, and dimensions are map string to interface. And this is what actually is produced right now. This is a materialized view of that instance, which is value 1 because that was already a constant, and then source workload and destination service are resolved to their actual current values. So now this is the information in the struct form that we are now going to send off to the next phase, which is to the handler using the template API. Now, handler is the code that receives this information and does with it what it wishes, basically. So Prometheus handler would take it, aggregate or massage the data depending on Prometheus's own configuration, and then expose it to Prometheus expose it to be scraped by the Prometheus server. The handler interface has a handle metric method, right? That handle metric method is dictated by which template it supports, and that's why we call it the template API. So the handler has to support whichever template API was defined earlier, and it takes an array of these instances, which are again defined on top. So now the last part, which we had just kind of so the last part is the handler, right? Like where does this go? So here we just define the interface. Now we actually want to see the Prometheus handler implement this interface. So Prometheus handler is defined as such, right? Like with the adapter and some configuration parameters that Prometheus actually needs. And this is an example of the actual Prometheus handler implementation. So it is implementing the interface that was defined a few slides ago. And this is the real implementation of Prometheus, of the Prometheus adapter. So as you can see, right, so we went at the top, we entered through the attribute API, which Envoy had sent. Then again, we augmented it by environment adapters like Kubernetes Env Adapter. We did attribute resolution, adapter resolution to decide which adapters apply and what instances apply. Then we produced the instances, and then we called those adapters. And in order to get a new adapter, you implement one of those APIs, and that's compiled into Mixer. So that gets into the next part, which is one of the big things that we were hearing early on was anytime you needed to create a new adapter, you had to compile it into Mixer. So what we did was, as you can see, right, the template API is already an API. And templates themselves are defined using a gRPC-based kind of a meta language, right? I mean, it is a proto, but it also is a DSL that defines the configuration format and the payload format both, and which is why it's a DSL. So then what we decided was it's actually better to have this picture instead of this, right? At that point, the template API produces these instances, and rather than handing them over to a handler that's compiled into Mixer, it sends them over gRPC to the adapter that's running outside. So how does that work, right? So now here you see the message template is kind of defined, and that has always been there, and it's in yellow. It's in the top left corner in case someone has some color issues. So that defines the template itself, right? So what the template is saying is, and you'll see that the template is both talking about how it's configured and what is the payload. Now, on the right-hand side, we generate new protos based on this original proto. One of them is instance message, and it looks very, very similar to the template message itself. The reason is I have actually elided some fields in it. For example, name is a field that we do stuff into instances, so that's why it is slightly different. But in terms of basic information, it's actually identical to the original proto. In order to create a gRPC service out of it, kind of following the standard conventions, we also generate a message called handle request metrics, which just has a repeated of this instance message in it. And then on the left-hand side, left bottom, you see that there is the actual gRPC service, which is defined, and it accepts a metric request, and it responds with a standard report result. So now what that does is functionally the gRPC adapter that's compiled in or the gRPC adapter that's running outside, the interface is actually very, very similar. It is still receiving that instance. And it's receiving the same information, but it is now decoupled from Mixer proper. So extensibility was one of the was the most important thing that we achieved by doing this, right? So now templates are no longer compiled into Mixer. They're not pure configuration. So an adapter author, if the adapter author wishes to define a new template, they can define the template using the proto, right, which is this. Then we have some code generation tools which would produce these other proto artifacts. They can write their own adapter and then package the proto descriptor. So there is a way to do to package proto descriptors as a transitive closure. So it includes all the dependencies of the proto. So for example, if you're using like Google gRPC status or something, some message like that inside your proto, it would package all that up in a transitive closure. And now that is data. That's no longer code. That descriptor is packaged as another CRD, which is the template CRD. And then Mixer loads all that data, and Mixer is now dynamically able to dispatch using template API, essentially synthesize directly on the wire these protos and call the services directly. So that has been a really well. I guess I'll let the community decide if it hasn't been how useful it has been, but I think it's pretty exciting that adapters don't need to be compiled in, and some of the use cases were that you don't want to open source your adapter and you don't want to compile it, and you still want to use stock Mixer, right? So this gives you all those things. I will pause here for a second. Does anyone have any questions?
Yeah, hi Manar, this is Vanil.
Hi.
So I was just curious about the handle metric part for gRPC adapters.
Mm-hmm.
So currently it also resends the adapter configuration. Are there any plans to separate out the configuration time calls with the metric time calls?
Yes, there are. So that is on the roadmap. So we have gRPC adapters have these two modes. One is session based and one is stateless or non-session based. The first one that we implemented is the non-session based. So it actually is stateless. So it packages up even the configuration and sends it out on every call. But we will implement the session-based adapter or session-based API as well, which will have a life cycle. So in the life cycle, it will first say initialize with some configuration, and then will no longer send the actual configuration on every call. So that is that's a performance improvement, and it is definitely on the roadmap. Are you observing any issues with it? Is that what you're asking, or just architecturally?
No, just curious because of the architecture. Yeah. Cool. Thanks.
Yes. Anyone else?
Yes. Question: how does this affect adapters that were written prior to that?
Prior to this. Okay. Yeah, that's a great question. So, well, actually, two parts to this answer. One is we are actually coming out with a formal document which we'll put on Istio.io, which will answer these specific questions, right, as to which adapters belong in Istio IO repository, in the main Istio repository, which belong in contrib, if at all, and which are to be hosted by vendors only, right? So that's kind of first question. Now, in terms of grandfathering in what is already there, we had accepted some vendor-specific adapters early on when we didn't have any of this. So we are going to have to kind of deal with them on a case-by-case basis. But if they can be moved out into their vendor repositories, then that's definitely preferred, so that we don't need to have that code inside the Istio repository. And there is, so we were planning to produce a tool, and actually I heard that someone already did produce a tool, so we should definitely document that. That takes the existing adapters and wraps them inside gRPC adapters, or does some code gen to create gRPC adapters from existing in-memory, rather in-process implementations. So, so it should be easy to move, and there would always be certain like simple or very heavily used adapters that are compiled in, at least for some time, right? So for example, Prometheus adapter itself, there is a very good chance that it will continue to be where it is, even though we do have an out of proc kind of example implementation of the same adapter. Actually, Doug can correct me if I'm wrong. I mean, do you see us moving to gRPC adapters for Prometheus? Oh, I guess. Okay, Doug isn't here, but but yeah. So to answer your question, there is going to be a very small set of adapters that would continue to be compiled in, and then we or the community will provide tools to take the existing adapters and move them into out of the repository. Does that answer your question?
It does, yeah, thanks.
Okay, so where can we go next, right, after this? So now, if you look at this picture, right, Envoy is calling Mixer, and Mixer is generating calls to the gRPC adapters. But, oops, sorry. The API between Mixer and gRPC adapters is well defined, right? That is the part of the Mixer abstraction. So in theory, Envoy should be able to make that call directly. So that is a possibility, and we are definitely thinking about that now that architecturally both these things are possible. But the good part is the abstraction does not change. The Mixer abstraction, which is why I said earlier, is to decide when something happens, how does it happen, and where is it sent to in the end. So maintaining the same configuration surface, both these things are possible, and they have their pros and cons, but both these things are possible. So that's what you can expect to see further, which is another reason why I have been encouraging folks to prefer gRPC adapters over compiled-in adapters, right? It kind of future-proofs you from any deployment or architectural changes. That's it. That's all I had. And like I said before, if someone wants to go into detail of any part, I'm glad to do so.
Yeah, hi, Manda. This is really interesting. What's next? I'm curious on this picture. Would Mixer, so if Envoy goes directly to gRPC adapter, would we eliminate the need of being centralized Mixer? Does it mean Mixer functionality being moved down to the sidecar?
Yes.
Okay.
Yeah, exactly. So Mixer, you can think of, has like two parts to it, right? One is what I sometimes call the Mixer front end, which receives things and decides which adapters apply and how to call them and all that. And then there is the part that actually calls out to the adapter. But to a large extent, this functionality moves down essentially to Mixer filter. It does open up a lot of avenues for more optimization. So for example, the problem that you alluded to earlier, which is if there is no policy that's deployed, then there is nothing to do. Well, if that code lives inside Mixer client, it actually knows and it just goes straight through. It doesn't need to call out to Mixer to a gRPC adapter in that case. So there are many advantages of that model.
Yeah. Definitely. Do you have motivation? It's interesting. You didn't break up Mixer to telemetry and policy, because now that Istio 1.0 has break up Mixer into two components. I always conceptually picture Mixer as two components now. So on this, what's next? I'm curious on, do you see any motivation to have Mixer telemetry running on the sidecar? Because I see motivation for Mixer policy.
Right. No, so okay, that's a great question. Yes, so for policy, like latency considerations are sometimes very important, and that means doing it closer to the proxy helps.
Mm-hmm.
Yes, so telemetry is not related in that regard.
Yeah.
But in that case, it becomes a deployment choice, right? If we have it set up in this way, then actually it still remains kind of a deployment time decision or a later on decision. But generally, it would be helpful, right, for similar reasons, to also not have the centralized Istio telemetry, but let the envoys. Let the Mixer client in Envoy send it to wherever it actually needs to go. There are certain conditions. So for example, if you want to restrict like firewalls, right? How many firewalls have access, how many endpoints have access to a particular IP and things like that. You can still manage that as a deployment choice. So gRPC adapters themselves are going to be services, and they can be scaled just like in anything else. So in that view, there is no reason to kind of hold on to telemetry as a separate deployable component, though.
Okay.
Yeah.
Because I was thinking, I mean, there's no obvious, I think there's a strong need for having policy running as sidecar. For telemetry, I think the needs is reduced because,
Correct.
like you said, it's not on the request path. I guess one advantage being having centralized telemetry is in a managed Istio environment.
Mm-hmm.
You will be able to, a cloud provider will be easily to manage the centralized component for the user, like in charge of its life cycle of upgrade, install. So that would be the advantage I would see.
So that's a good point. However, if you look at how gRPC adapters are working even now, right? What you really upgrade is the gRPC adapters themselves. So you upgrade the implementation, and if you actually make a change to the template, that is just a configuration change. So with that view, you don't actually need to upgrade Mixer, and Similarly, you don't need to upgrade Mixer client, which is running in Envoy.
So
Because,
you'd be
because
upgrade
if
the
everything is code,
adapter.
right? Yep.
Okay, I see your point. And then in this picture, you would consider the adapter to be part of the control plane with Mixer if
That's
Mixer
correct.
exists, but then the data plane would still be the proxy.
Correct. That is correct. And we have, there are already several people who have written gRPC adapters, and I'm very, very glad that that's happening.
Yeah, IBM wrote one for New Relic. In fact, we want to put in a contribute repo, but you and Martin hasn't formalized the process.
Correct. Yes. So that will come within the next few weeks.
There's also a gRPC contrib repo that we could toss it in as well.
From that, yeah, we should consider that as well.
And I like, you might know someone that has some perms on that repo. So
right. Yep. Yes. Indeed. Yes.
Yeah.
Okay. Well,
and this is not 1-1, right? Sorry.
No.
It's
no, God,
change.
no. This is not 1-1. No, this is.
Okay. I should shut up. Thank you. Really good information.
Yeah, there are plenty of things that are already on 1-1, and we don't want to add to that.
Yep, makes sense.
Thank you so much, Mandar, for doing this. This was great.
Yeah,
thank
good.
you.
I said it in the chat, but I'll say it here too. We did record this, so I'll get the recording on our YouTube channel today, and we'll share the deck as well. We do have one question in the chat. Does the Mixer pose a networking bottleneck in the event of scaling up network-intensive containers like databases, messaging systems like Kafka?
So the short answer is no, because none of the data path traffic actually goes through Mixer, right? So Mixer is only dealing with headers and metadata about the requests, so the volume of the data doesn't really affect Mixer.
Cool.
And lastly, I have liberally used in this presentation. I've liberally used stuff from Zach and Doug. So thank you to both of them. I don't know if they're on the call or not, but that it was awesome for me to be able to draw from some existing material and then create some more stuff. So thank you.
Yeah, I see Doug's here. Thank you, Doug, for being here and answering some questions in the chat as they came up. And I don't see Zach, but we think Zach is awesome. So it's great that we're able to collaborate on all of the many presentations and discussions people have had around Mixer before. So always good. And someone else can take the deck and fork it and make it their own too going forward. So, oh, look, you got a nice photo there. Very nice. It's not a sailboat though, so.
No. All right.
You know how I love my sailing photos. Oh, that's right. Doug says you sail under. So yeah, it still works. Awesome. Thank you again, Mandar. If anybody else has any questions, feel free to reach out on the mailing list or join the working group, of course. Couple of other things on the radar for Istio-ness. Lynn, you were just at Container Camp, right? How did that go?
Yes, it was 2 weeks ago in London. It was a very well attended conference. It's a small conference. It's my first time being there too. It's about 300 maybe to 400 technical folks, very technical topics. And so I was able to give Istio talk on, give what is Istio, why Istio, and the update of Istio to 1.0. So it went pretty well. And
Great.
The conference has a good diversity of other container-related topics. And somebody interestingly even tweeted about there's no container conference without Istio content now. So that was interesting.
Well, that's cool.
Yeah, it's a really good conference. In general, they run, I think they run 2 or 3 times per year in in Australia and UK, and they're also looking at New York in the US, maybe for next year. Yeah, I think it's a good conference. Definitely good to get some Istio highlights in there too.
Great. Yeah. So I just wanted to put the word out. If anybody's interested in presenting about Istio anywhere, I'm starting to see more conferences and meetups and things that are looking for speakers on Istio. So please do reach out. Again, we have decks that we're happy to share, and you can edit as needed. Lynn was just at the Container Camp. There's a Container Conf that I just saw on Twitter that's covering a lot of microservices stuff. So it also has an Istio session that looks to be happening in Germany in November. So there's a lot of interesting. I feel like we're out of summer, so the conference wave is picking up again, and it'll culminate in KubeCon, and then we'll be quiet for a little bit. But if you're interested in doing any sort of presentations, not only can we help with content, but I'm also happy to help with diagrams and things like that. We have a design service that I'm happy to set folks up with that they can use to have things look pretty. We're actually also working on a Istio branded template. So that would also be another nice, pretty thing for folks to use when you're doing presentations. But definitely do reach out. And if anyone is interested in leading a workshop in Berlin in October, ping me because we do have someone who is looking for someone to kind of co-lead. So that's an opportunity if you're interested in speaking. Other than that,
there will be beer.
I would assume so. I mean, that's up to But yeah, I think when you're there, it's a requirement to sample the local food and drink. So, but yeah, definitely keep an eye out for some of the great conference community stuff. It'll be on our community calendar. And again, if you want to add some stuff, let me know. I know there's a meetup coming up in San Francisco, and we are hoping to get our regular meetups going as well in the Bay Area. There are also some Istio meetup groups in London, of course. I know London is meeting again soon. And if you're interested in starting one in your area, please reach out. Happy to help you and get you set up. Yeah, so that looks to be all we have for today. We will chat again in 2 weeks. And of course, if you have anything else you need help with or want to talk about, don't hesitate to reach out. Thank you, everyone, for joining us today.
Thank
Bye.
you.
Thanks. Bye.
Thanks. Bye.
Thank you. Great presentation.